All right, so this lesson is all about optical illusions. Whether you know it or not, optical illusions are created using figures of geometry. It's just different ways that they are put together and connected that causes the illusion to be misleading in some way, and it can be perceived in many different ways. So let's just check out for fun some different types of optical illusions that are created using geometric figures. So this is a popular one. The question would be, is this window on the right side or the left side? Again, no right or wrong answer. It's how you see it, and it can change when you're looking at it. But again, those geometric figures and how they're arranged are, in a sense, meant to be misleading. How many legs does the elephant have? It gets tricky the more you look at it. The one at the top there, rabbit or a duck, that's a famous optical illusion, and the same on the bottom. Do you see a vase or two people? How many faces can you see? Could this figure actually be real in life? In this subway, this guy spray painted the wall to appear as an illusion of the stairs coming out of the wall. Again, it's all about angles, lines, planes, and how they're connected that creates the optical illusion. All right, so down to kind of the nuts and bolts of our class. So illusions create images that, again, may not be what they appear to be on your first glance. They can stump your senses. That's why we create them, because they're kind of fun. So two main tools that are used in geometry to bust illusions are the following. The first one is a straight edge, which would be any object in your house that can be used to compare lengths, line up objects, or extend lines. It doesn't have to be something that has a measurement on it, because you're mostly determining if lines are straight, and you can come up with techniques to measure for the sake of comparison, not for the sake of identifying how long it is per se. And the second tool that is commonly used is a compass. However, we're going to kind of ignore this one since we're working remotely and not all of you will have access to a compass. But it is used to draw arcs and circles and compare lengths as well. So we're going to be focusing on the straight edge. All right, so here's some examples of what I mean. So a straight edge can determine if sides of a triangle are straight. So if you look at that first figure there in the top left hand of your corner, you may kind of, again, that optical illusion is making you perceive those lines of the sides of your triangle as being kind of bent. So in order to tell if it is actually truly bent or it is to bust the myth, what you do is you take a straight edge. Now I'm just using a black square that I created on my computer. You can grab anything. If you saw in the diagram before, you can use a pencil, you can use the side of a folder, you can use anything that is straight and determined to be straight. So what I'm going to ask you to do is we're going to determine if the side of this triangle is straight by putting it against something that is straight. So again, my rectangle is completely straight on my computer. All I'm doing is kind of tilting it from left to right so that it matches up. And if you look, when I put it up against it, that black distinct line matches up directly with the side of my triangle. So it actually indeed is straight. So your answer would be, is it straight? Yes, it is. Oh. So it definitely is straight, even though, again, when you're putting it up against those circles, it appears to look kind of wavy. All right, take a look in the second one. Use a straight edge to determine which of the three segments connects with this bottom line. So again, just kind of eyeballing it, I would say it's maybe the middle line sticking out there at the top. So how you would figure that out is, again, I'm going to put my straight edge and I'm going to line it up with the bottom one, and I'm going to see what line it matches up with. So indeed, this one, I actually did see it right first time. It would be matching up with the middle line at the top. So again, you can use a straight edge to determine different items like that. You can also use a straight edge just to compare lengths. Again, you're not looking to identify how long something is, you're just looking at it to compare. So again, here is my kind of generic rectangle that I'm using as my straight edge on my screen. Again, you could pick anything. You can even pick a piece of paper and put it up again. So we're looking in this one just to say, hey, is CB, line segment CD, the same length as AB? Now, on my first hunch, I'd say no, but it's always good to double check in geometry and, again, bust those illusions that may come forward based on facts. So if I would put my straight edge up to here, now if this was a sheet of paper, you might make a little tick mark on your paper to identify where it stops. I have the convenience that I can shorten my box and say, all right, CD is this long. Now I should be able to spin it around, okay, right? And put it up against line segment AB and determine if it's the exact same length. It is the same length. So although it's kind of like an illusion, I would have said, looking at the picture, that line AB is absolutely longer than CD. But again, when we compare it with actual data and we look at it, they are in fact the same. So I'm going to just write a typo here, same length. Okay, here's another. Which is longer? Line segment AB, which is right here in our angle, or BC? So again, not really sure. I don't feel confident just kind of making a guess. I could, but it's always best to check using resources. So again, I'm just going to start with the one on the bottom, and I'm going to flip my straight edge. Hopefully this is easier for you guys at home when you can just use an object that is handy and manipulate it with your hands. This is not the easiest, but I'm going to line it up here and extend my box here. So I'm looking at the length from that corner there over to my C value. So that is the approximate length. And again, if you're using paper or a pencil, you can make a little tick mark of where that ends. And then again, you're going to flip it and line it up with the second item that you're looking to measure to compare. So in this problem, AB is definitely longer than CB because when I put it up to line AB, it is short in reaching that point A. Even if I slid it up here, you could say it's short in reaching B. So my answer for the second one, when we're saying which one is longer, AB is longer. All right, guys, so that's the end of this lesson. It's just about busting optical illusions. So grab yourself a straight edge at your house. For your practice assignment, you'll be asked to take a look at some popular optical illusions and see if they are actually valid or bust them. Good luck.